In most of the videos where we did technical stuff, I've been recording and playing on a ThinkPad with Linux that doesn't have the best graphics card, so you had to endure this low FPS footage. After editing last video, I realized, wait, I just developed a TCP network proxy, which means I can run the game on any of my machines and just have to make sure that the traffic goes through my proxy. I'm an idiot. So now I can just change the game server IP on my Windows Gaming Battle Station to point to where the proxy is running. So enjoy these epic graphics for a bit. So like last episode, I continued to look at a few more packets and implemented them. Nothing special. There's a sneaking toggle, weapon reload, and a respawn packet when you die and click respawn. And when you now play the game, there are very few packets from the client to the server that we don't know about. Pretty cool to see. By the way, one of the bears dropped me an AK-47. Look at how cool that is. But one of the more interesting packets we haven't looked at can be seen when we pick up drops from those bears. Like this blue one I forgot to pick up. Which by the way turns out to be the Zero Cool magic spell. In our Let's Play, we got that drop from a boss spider in the Fire and Ice dungeon. And if you don't understand this reference, Zero Cool, mess with the best, die like the rest, then please stop watching my video right now and instead watch the movie Hackers. Anyway, we gun down a few more bears with the AK, and then we can collect a few more packet samples. Let me clean up the output really quick and remove the obvious and already known position packet. So this seems to indicate an item pickup. One interesting and important observation is that one of the drops gave us 2 items, but we still only saw one of these packets. Also, the amount that we got of something doesn't seem to be encoded in the packet either. And we also got sniper ammo twice, and still the value is unique here. All this evidence combined leads me to believe that this must be some kind of drop ID, and the packet is something like pick up the drop with this ID. And so here I implemented a parser function for it. And then we can test it. Let's hunt some bears. And there are 2 more observations that we can make with this now. First, the ID seems to be predictable and incremental. And the second one is, which is actually something I wanted to try, and that is sending the same packet multiple times. I don't know why that happens. I assume it's a small bug of the client and some kind of hiccup that it sent it multiple times, but it definitely didn't result in us getting the same item a few times. I wanted to try that because I was wondering if we can duplicate item drops that way, but clearly the server doesn't allow that and the drop can only be picked up once. However, I wonder about another thing, but for that we need a new feature of our proxy. I want to be able to inject packets into the communication. We can use the little command loop we have written here for that. So far we only have a quit command, but now I want to add a send to server and send to client command. To do that, I define 2 commands that start either with S or C, indicating where I want to send it. Then I have to look for a game server that is connected. To do that, I add another attribute into the proxy class that we can set to true when we have a connection. This allows us to loop over all the game servers and see which one has a client connected to it. And then we just, based on which direction we want, have to get the reference to the socket on which we can then call send all. Now, over the network we want to send raw bytes, but our command line input has to be text. So I think we can just make sure we enter hex data, and that is then decoded into raw bytes and then sent to either the client or server. I also make a small modification in the parser so we can get the whole packet that was sent. So let's head in-game and shoot a fireball. This is the packet we sent. You know how the packet is structured from last video, but now with our new feature we can simply say we want to send a packet to the server with capital S, followed by the hex encoded data. And boom, we just told the server to create a fireball. Amazing, right? Now let's play with the item drops. We know it's easy to guess once we have a valid ID. So let's kill some bears until we get a drop. Now we just have to collect it and look at the ID. Cool. So now we just have to make sure we have a few more drops laying around, and then we just try some other item IDs in the range, and maybe we get lucky and get the correct item ID. Look, we just picked it up by faking a packet and didn't have to walk to it. We could create an Autoloot feature if we could figure out the IDs of items. Our client has to know somehow, right? Well, so far we only looked at packets from the client to the server, and from what we have seen, it's actually fairly simple what the client does. A lot of the actions, like which items we pick up, if we killed something and so forth, is calculated on the server. We just say we want to pick up the drop, but not we want 6 sniper bullets. So the protocol is not designed too badly. It doesn't trust every fake info by the client, except of course the position, which we use to fly and teleport around. So I think it's time to look at some server packets. For that we have to remove the filter to exclude server packets. And we get flooded with a lot more info. In fact, I noticed that when I walk here a few steps back and forth, that here I only get zeros, nothing. And here, where I'm closer to the forest with the bears, then I get a lot of data, which goes away again when we walk back. So first of all, we have a small 00 empty packet, which we can add the parser. But then what's up with this data? I assume what we witnessed here is a boundary between zones. And this is the zone with the bears. And this one doesn't have monsters. So the server only sends us the monster information if we are close, and doesn't when we are further away. Saves traffic and also local computation on the client to handle these actors in the world. But in any way, we can copy a few examples of these packets and quickly analyze it. Of course, the first 2 bytes is the packet ID again, and we quickly see that it appears multiple times in there. And if we align them below each other nicely, we can also super easily see the format. Packet ID, some kind of other ID, maybe monster ID. Then this part here, which was changing all the time when we saw the data in real time printed by the proxy, it's probably also position data. So the XYZ position of the monster, and then we have some other values that I have no idea what they are for. But whatever, let's implement the parser for what we got. And that's super simple. We extract the ID as an integer, XYZ as a float, then for the remaining data we also unpack it as integer for now. And then we print it. And when we now go into that area, we see a super awesome output of the actors in the area. So if my assumption that these are the bears in this area is correct, we should be able to kill one, and that should remove an entry here. So boom, and quickly have a look and compare before and after. And yes, there's one entry missing. Awesome. But does this list also contain item drops? Because the IDs look fairly similar. Let's pick up one item and look for that item ID in our output. So it looks like the ID of the item drop is in kind of the same unique ID system as these monsters. It would fit in here, but it's not there. So this is really just monster data. So where do we get the item drops? I removed the output of the monster position again because it's very spammy. This way we can more easily catch new packets. One unique packet I noticed was arriving right when I joined the game. So let's look at that one. It's quite big. Again, we can split and arrange the data based on the first packet ID. And so there were obviously a lot of them that look very similar. And it looks kind of similar to the shooting a weapon packet, as there are ASCII characters. And so I guess here the length. You can again look for similarities and line it up, and it becomes very clear. What this data back here means, I don't know yet, but let's explore what kind of names there are and start implementing the parser. So I guess this is another ID as it was incremental, and again a length, some text, probably a name of some sorts, and then at the end a bit more stuff. So let's check it out. We relog into the game and look at that. It contains initial actor information, the bush from the spawn, some NPCs, but also the golden eggs. So this is actor information. I'm wondering, is the other data behind maybe again position data? So let's parse that as floats and print it too. Relog again into the game, and here we go. Awesome, look, this is the real position of the eggs. I recognize this one because I was using it as an example when we reverse engineered the setup in the disassembly. Which is so awesome because this is the third option on how we could have gotten the position of the eggs to solve it. First, we did it through dynamic analysis by accessing the object in memory with LD preload and hooking stuff. Then we found it with static analysis where they set up the eggs and use hard-coded position values. And now we have a third path through network traffic analysis. I think that's really awesome that there are so many ways how you could have solved it. At least part of it for the Balmer's eggs you would have had to reverse engineer some of the code probably. Let's see if the same packet is also used when a dead monster drops items. Let's find a bear, kill it, and there we go, white drop. And here we get the idea of the white drop. Let's implement auto-looting with that. We just have to send the packet with the item ID, but to do that we have to do some modification of our proxy and parser for that, because we don't have a reference to the socket in the parser to just write and send this pickup packet now. And I actually did that first. I added a server and client variable that I set from the proxy with the socket reference, and then I could send out the packet from inside the parser. But that just broke everything. The socket didn't like it to be called from different threads, and it always broke. So what I did instead was I created a queue where I can add packets I want to send out either to the server or game client. And then in the proxy thread that handles the specific socket sending direction, I check if there are items in that queue, and if so, I pop one off and send it out. It's not perfect. I used a regular list and not a thread safe queue. It also didn't loop over the queue to send out multiple items, and it only does it after it receives the packet before. But whatever, I just wanted to get it to work. So now theoretically, when a drop is detected, the pickup packet is placed in the queue and then shortly also sent to the server. So let's try that. We head into the game and shoot some bears. And look, we automatically pick up the drops, even from bears super far away. That's awesome for farming items. And holy hand grenade? What is that? I want to throw it at some bears. Boom! This is amazing! Apparently it was a purple drop that must be super rare. This is a holy hand grenade, a legendary grenade, and does 300 damage, and it has a 10-second cooldown. Blow thine enemies to tiny bits. Thy foe, who being naughty in my sight, shall snuff it. What an epic end to an episode.